We're working through some examples of expressing decimal values as fractions, so keep watching. I'm Allison from Math Bytes, and we're doing some examples of expressing decimal values as fractions. So here's our first problem. Write 0.13 repeating as a fraction. All right, so let's set n equal to our value, 0.13 repeating. Now remember, that's 0.1333, etc. Let's multiply n by 10. So 10n is equal to 1.3 repeating, or 1.3333, etc. Now remember, the point of this whole procedure is to have all those repeating decimal values disappear when we do subtraction. Now that's not going to happen just yet. So let's multiply n by 100. 100n is equal to 13.3 repeating, or 13.333, etc. Now if we were to subtract 10n from 100n, those repeating decimal values would disappear. So let's do that. 100n minus 10n is equal to 13.3 repeating and 1.3 repeating. Now when we do that subtraction on the left, 100n minus 10n is 90n. And on the right, we get 12. Those 3 numbers after the decimal place, they just all cancel each other out with the subtraction. So now we have 90n is equal to 12. Or n is equal to 12 over 90. Now we need to reduce that. I can divide both those numbers by 3, for example. 12 divided by 3 is 4. 90 divided by 3 is 30, so I have 4 over 30. I can reduce those again, both by 2, and I get 2 over 15. That's in lowest terms. So our fractional representation is 2 over 15. Okay, here's our next problem. Write 0.4025 as a fraction. Now I'm going to do this a little bit differently than I did a problem like this in our Math Bytes video on this topic, just so you can see it worked out a little bit of a different way. All right, so I'm going to say n is equal to our value, 0.4025. So 10n is equal to 4.025. 100n is equal to 40.25. 1000n is equal to 402.5. 10,000n is equal to 4025. I'm out of decimal values here, and that's what I want. So n is equal to 4025 over 10,000. Now I can reduce. I can reduce both those numbers by 5, and I get 805 over 2,000. I can reduce both those numbers by 5 as well, and I get 161 over 400. So that is my fractional representation. So all I did was multiply by increasing powers of 10 until I had eliminated everything on the right side of the decimal point and moved it to the left. Okay, here's our last problem. Write 1.6 repeating as a fraction. All right, so again, I'm going to say n is equal to our value, 1.6 repeating. That's 1.666, etc. Now, that means that 10n is equal to 16.6 repeating, or 16.666, etc. Now I can do my subtraction, and I get 10n minus n is equal to 16.6 repeating and 1.6 repeating. Now 10n minus n is 9n. 16.6 repeating minus 1.6 repeating is 15. All those repeating decimal values cancel each other out. So now I have n is equal to 15 over 9, and reducing by 3, I get that n is equal to 5 over 3. Now that's an improper fraction, but we would expect that because our original value was greater than 1. To learn more about this topic, watch our videos on the Math Bytes with Allison YouTube channel.